All right, here's part 2 of our simplifying radicals lesson. We're going to be rationalizing the denominator and looking at some application problems. Now, in order to do this particular application problem, we're going to have to review the Pythagorean theorem. So hopefully you remember the Pythagorean theorem. In the Pythagorean theorem, we have two legs of a triangle, A and B, and then we have its hypotenuse, C, the longest side. And in order to find this side, or in fact to find any side, we can use the Pythagorean theorem, which is a squared, so the length of a squared plus the length of b squared is equal to the length of c squared. So if we can have either two legs or a leg in the hypotenuse, we can find the remaining side of the triangle. And that's what we're going to use to solve this problem. A museum has a rectangular entry door that is 3 times as tall as it is wide. Give a simplified expression for the maximum length of a painting that could fit through the door diagonally. So we're looking at coming through the door like this to get the maximum size of our painting. So we know that the length, or the height rather, is 3 times as tall as it is wide. So our width and our height. So we have 3 times W is the measure of the height of the door. And what we're going to need to do is find this right here. So we will use the Pythagorean theorem. We know the Pythagorean theorem is a squared plus b squared is equal to c squared. So we say that w squared plus 3w quantity squared is going to be equal to c squared. And we square both of those. Well, we know that w squared is just w squared, and 3w squared is 3 squared, or 9. W squared equal to c squared. And we know that we can combine our two like terms. So 9w squared plus w squared is just 10w squared equal to c squared. Now we come to the problem. In order to get the value of c, because we want c, the length of the hypotenuse, not c squared, then we have to take the square root of c squared and the square root of 10w squared. Well, the square root of c squared is going to give us c, that's easy. And we know that we're going to end up with a w, right? And we're going to end up with the square root of 10. So the square root of 10 times w equals c. We always like to have our radical to the right of our numbers. So w times the square root of 10 is equal to c is our answer. Let's look at simplifying using the division property of square roots. We're going to simplify our radicals using the division property of square roots. And what the division property of square roots says is that if I have a fraction under a radical, I can take the square root of the top and divide it by the square root of the bottom, that is equal to the square root underneath the radical, and then I can simply take the square root if they're perfect squares and use them as a fraction. So in our first instance here, we have that 64, square root of 64 over 49. Well, we know that the square root of 64 over 49, according to the division property of square roots, is equal to the square root of 64 over the square root of 49. And we know that the square root of 64 is 8 because it's a perfect square. And the square root of 49 is also a perfect square. So we know that our answer is going to be 8 over 7. We can quickly apply that over here as well. We can write the square root of 36a over 4a to the third as the square root of 36a over the square root of 4a to the third. And then we need to do a little bit of work here. We know that the square root of 36 is 6, so we can put that on the outside of the square root symbol. Square root of 36 is 6. And we can't do much with the square root of a, so we'll just have to leave that. The square root of 6 times the square root of a over, and we know the square root of 4 is 2. And we can split this up into a squared times square root of a, which leaves us with 6 times the square root of a over 2a square root of a. Now we are not quite done here. You see, we have some more simplification that we can do. 6 divided by 2 is actually 3. So we can have 3 square root of a on the top. That gets rid of the 2 on the bottom and leaves us just with a times the square root of a. And it looks like we might be done, but no! We still have one more thing that we can do, because a, the square root of a, divided by the square root of a, is actually 1. So these two cancel each other out, leaving us with 3 over a. And that is our answer. At this point, we've got lots and lots of tools. We've got multiplying radicals. We've got using the multiplication property of square roots to simplify radicals. We've got the division property of square roots. We're going to add one more to it. We're going to talk about rationalizing a denominator. Now, that is a mouthful. We're talking about rationalizing a denominator. We remember that one of the rules of simplifying our radicals is that you cannot have a radical symbol, a radicand, in the denominator. So how do we get rid of it? What can we do to get rid of it? Well, we want to rationalize those. And rationalizing, that means making it into a rational number. You'll remember that the square root of 7, right, is not a rational number. It is an irrational number because it's not terminating and it's not repeating, so it's not a rational number. We're going to rationalize it. And in order to do that, we'll remember that, well, if we have the square root of 2, for example, and we want to, multiply that by itself, multiply that by the square root of 2. If we multiply the square root of 2 times the square root of 2, what do we get? Well, we get 2. Now that's very helpful if we want to get rid of a radical in the denominator. What we can do is actually multiply the denominator by the square root of 7. But as you know, we can't just multiply things by things without any consequences. But what we can do is we can multiply by 1 without any consequence whatsoever, because it always gives us the same number back. What would give us 1? Well, multiplying the square root of 7 over the square root of 7, because square root of 7 divided by square root of 7 is 1. And when we do that, on the bottom, we'll end up with the square root of 7 times the square root of 7, which is just 7. And on the top, we'll wind up with the square root of 3 times the square root of 7. And we can simplify that further, right? Because we can multiply these two together, and that'll give us the square root of 21 over 7. No longer do we have a radical in the denominator, so we are simplified as much as we need to. Let's try to take a look at another one. Let me move me over here, and we'll try this one. Square root of 5 over the square root of 18m. Once again, we cannot have our radical in the bottom, so in the denominator there, so we're going to have to multiply by square root of 18m on the top and on the bottom. And when we do that, on the bottom, we'll get simply 18m. What does that leave us with on the top? It leaves us with the square root of 5 times the square root of 18m, because that extends over that, right? Do you remember that? And then we will remember our multiplication property. We can multiply 5 times 18m, those two square roots, and that's going to give us the square root of 90m, square root of 90m over 18m. And can we simplify further? Well, yes, we can, because the square root of 90m is the same as the square root of 9 times the square root of 10m. All underneath the radical there, all over 18m. And then when we take the square root of 9, we're going to get 3 times the square root of 10m, all over 18m. And then we still have a little bit more simplifying to do, because 3 and 18 share the common factor of 3. So we can rewrite that as the square root of 10m, right? Because 3 divided by 3 is 1, and we don't write down the 1, over 18 divided by 3, which is 6m. So that our answer is finally square root of 10m over 6m.